Now we want to apply linear equations to solving problems. So I know the first instinct for most of us is to tense up when we see some word problems. So hopefully we have a good variety here so that you get comfortable with how to approach these types of problems, so you'll know what to do should you see something similar to this on a test. In our first example, a total of 650 tickets were sold for the school play. They were either adult tickets or student tickets. There were 50 fewer student tickets sold than adult tickets. How many adult tickets were sold? Okay, well, since we're dealing with algebra, whenever you are looking for something, so we're looking for the number of adult tickets sold, we want to assign a variable to it since we don't know it, and that's what we're trying to find out. So I'm going to let A equal the number of adult tickets sold. So you could have used X, but sometimes using a more descriptive variable is easier because it makes it easier to remember what it represents as you're going through your problem. Okay, so we have A as the number of adult tickets sold. Notice in the problem they told us there were 50 fewer student tickets sold than adults. So what expression can we write to represent the number of student tickets sold, since there were 50 fewer? Okay, well, 50 fewer means we're going to take that original number A and we're going to subtract 50 from it. Okay, so we have A adult tickets, A minus 50 student tickets. And now, since we're trying to figure out how many adult tickets were sold, we're not done yet. We have to use the other bit of information we were given, and that's that there were a total of 650 tickets sold. So that means if I take the number of adult tickets and I add to it the number of student tickets that were sold, what should that equal? It should equal the total of 650 tickets. Okay? All right, so now that we have our equation, we're going to apply what we were doing previously and solve it. So we need to combine our like terms. A plus A, remember there are those understood ones in front of the A's, so that gives us 2A minus 50 is equal to 650. So next I need to add 50 to both sides so that I can get my variable isolated. And once we do that, we have 2A is equal to 700. And my last step is to divide both sides by 2. And we get that A is equal to 350. Okay, so have we answered our question? We wanted to know how many adult tickets were sold, and that's what A represents. So I'm just going to write my answer as 350 adult tickets. Okay, let's go to problem or example B. The length of a rectangle is 6 times its width. If the perimeter of the rectangle is 126 centimeters, find its area. Okay, so let's draw a picture. I'm a visual learner, so it helps me to draw an illustration when possible. So don't hesitate to do that. Okay, well, we know the length is 6 times its width. Okay, well, I don't know what the width is, so we're going to assign a variable to it. And I'm going to use a descriptive one. We're going to let W represent the width. So if W is the width, how can I represent the length if the length is 6 times the width? Okay, well, 6 times means we're just multiplying 6 times whatever the width is, so that'll give us 6W. Okay, so that's the first part. We have our variables in place. Now we need to use the fact that the perimeter of the rectangle is 126 centimeters. Well, the perimeter of any object is just the distance around the object. Okay, so perimeter is the distance around the object. So to find the distance around our rectangle, all we have to do is add all the sides together. Now you may remember a formula for the perimeter of a rectangle is 2 times the length times 2 times the width. If so, that's perfect and you can apply that. But just to keep it general, whenever you think of perimeter, it just means the distance around the object. You want to add all the sides together. So we can do that literally. So we have 6w is the length of one side, plus w is the length of another side, plus the other long side at the top has a length of 6w since it's a rectangle. And then our remaining side is w, so plus another w. So that's our perimeter, and we know it's going to equal 126. So now we have our equation to solve. So we combine our like terms. Remember that there are 1's in front of those w's. So we have 6 plus 6, which is 12, plus 2 more is 14. W is equal to 126. And now our last step is to divide both sides by 14. And we end up with W is equal to, and then just put that in your calculator, 126 divided by 14 is 9. Okay, so now we need to make sure that we've answered the question that's being asked. We have not. We want to find its area. Okay, so how do we find the area of a rectangle? It's the length times the width. So we just found that our width is equal to 9. So that means that our length is 6 times that. So 6 times 9 is 54. So our area is going to be our length, 54, times our width, which is 9. And we do that product and we come up with 486. Since each of those are centimeters, 54 centimeters is our length, 9 centimeters is our width. Centimeters times centimeters gives us centimeters squared. All right, and that would be our answer. For part C, Clarice rented a truck for one day. There was a base fee of $19.99 and there was an additional charge of 75 cents for each mile drive. Clarice had to pay $197.74 when she returned the truck. How many miles did she drive the truck? Okay, so dealing with algebra, we're going to put a variable in there for what we don't know. So we're looking for the number of miles she drove the truck. So we're going to let that represent m. So let m equal the number of miles driven. So now our task is to come up with an equation. Okay, so we know that there was a base fee of $19.99, an additional charge of 75 cents per mile, and she had a total cost of $197.74. So we're going to write an equation to represent the cost. So if she started off with a base fee of $19.99, we know added to it was 75 cents per mile. So if there are a total of m miles driven, that means she's going to have to pay 75 cents times m, whatever the number of miles is. Well, once we add that together, this should give us her total of $197.74. Okay, so now we have our equation. So we need to subtract 1999 from both sides. And we're left with 0.75 m on the left. On the right side, when you do that difference, you end up with 177.75. So our last step is to divide both sides by 0.75. So on the left, we're left with m, and you should come up with 237. Okay, so now we need to see if we've answered the question that was asked. How many miles did she drive the truck? M represents the number of miles, so now let's just put our units in there. So she drove 237 miles. Okay, going on to part D. The manager of a store selling tea plans to mix a more expensive tea that costs $6 per pound with a less expensive tea that costs $4 per pound to create a 150-pound blend that will sell for $4.80 per pound. How many pounds of each type of tea are required? For this one, I'm going to start off with a picture. So we're mixing types of tea. So this is called a mixture problem. Whether you're mixing types of juices or in chemistry, types of acid, these would be mixture problems that will be approached a similar way. So the first tea costs $6 a pound. We're adding to it another type of tea that costs $4 a pound to come up with a tea that's going to cost $4.80 per pound. Okay, so the first equation that I'm going to write is just going to represent the amount of tea, just so that we can get a visual going here. So the amount of tea, and we're talking about pounds of tea. Okay, well, we're actually trying to figure out how many pounds of each type of tea are required. So since we don't know that, we can put in a variable. So I'm going to let P represent the number of pounds of $6 tea. Now in the problem, they tell us that we want to come up with a 150-pound blend. So I know I want to end up with 150 on the right side. Okay, so if we have a total of 150 pounds, and P pounds are the $6 per pound tea, how much do we have left for the $4 per pound? Well, we're going to take that total of 150 and subtract P from it. Okay, so when I add these together, we do end up with the 150. All right, so now we have a variable representing the number of pounds of each type of tea. Okay, well, next we need to come up with an equation for the cost. All right, well, if we have $6 per pound and we have P pounds, that total cost is going to be 6 times P. Next, if it's $4 per pound and I have 150 minus P pounds, we're going to multiply 4 times 150 minus P. And lastly, if it's $4.80 per pound and we have 150 pounds, we're going to multiply those two together. Okay, so the second equation is representing the cost. And notice that's an equation that we can solve and figure out what P is going to equal. Okay, so we're going to start by distributing that 4. So just making a note that that's the equation we're working with. So 6P plus 4 times 150 gives us 600, minus 4 times P is 4P. 480 times 150 is 720. Now we combine our like terms. Hopefully this solving linear equations is starting to seem more routine. So 6 minus 4 gives us 2. We still have our p. Plus 600 equals 720. So now we need to subtract 600 from both sides to isolate the p. So we have that 2p is equal to 120. Divide both sides by 2. And we end up with p is equal to 60. All right, so now let's look to see if we've answered our question. How many pounds of each type of tea are required? So we haven't quite answered it. So we need to say how many pounds of $6 tea and how many pounds of $4 tea. Well, the number of pounds of $6 tea is exactly p if you look right under our figure. So p we have is equal to 60. How many pounds of $4 tea? Well, we just do 150 minus 60. And that gives us 90. And that would be our answer.